Hello, everybody. Welcome back to James's Adventures in Chemistry. Yes, James, everyone's favorite, is back. So today we are going to be learning about balancing chemical equations. So we're gonna go ahead and start off with an example problem. Uh, Future me, go ahead and put up that problem on the screen there. Yep, there it is. So it looks good. So this example problem, it gives us KO2 plus H2O yields KOH plus O2 plus H2O2. So we've got to change these coefficients so that the reaction is balanced, which means that there's the same amount of elements on each side of the equation. So just by kind of looking at it, we can see that K is going to be the unique element here. So the number of moles of KO2 and the number of moles of KOH are always going to have to be similar. So let's look at what else we've got. We have an odd number currently of oxygens on the right side. We have an odd number of hydrogens on the right side, but we have an even number of hydrogens on the left side. So let's go ahead and throw a 2 in front of the KOH on the right side. And now we've got two Ks on the right side, so let's go ahead and throw a 2 in front of the KO2 on the left side to go along with that. And then if we go ahead and look at our oxygens on the right side, we've got 6 oxygens. But on our left side right here, we only have 5 oxygens. So let's go ahead and slap a 2 in front of the H2O also. So we get 6 oxygens on both sides. So our final formula is going to be 2KO2 plus 2H2O yields 2KOH plus O2 plus H2O2, which means that there's 2 Ks on each side, there's 6 O's on each side, and there's 4 H's on each side. Alright, that's it for that question. So let's go ahead and go into the next question. Alright, so this problem goes ahead and gives us NH3 plus O2 yields NO plus H2O. So we can figure out that nitrogen is going to be the kind of unique element here, which means that the number of moles of NO and the number of moles of NH3 are always going to have to be the same. We have an even number of hydrogens on the right side and an odd number on the left side. So we're going to go ahead and put a 2 in front of the NH3, and we're going to put a 3 in front of the H2O, so that the hydrogens are balanced. But now, since there are 2 nitrogens on the left side, there have to be 2 nitrogens on the right side, which means that we've got to put a 2 in front of the NO. Now, here comes the tricky part. Let's count up our oxygens, shall we? On the right side, we currently have 1, 2, 3, 4, 5 oxygens. But on the left side, we can see that our only source of oxygen is O2, which means that on the left side, we can only get an even number of oxygen. So this makes everything more complicated because we have to now multiply all the numbers that we have now by 2 so that we can have an even number of oxygens on the right side. So right now, what we have is 4 NH3 plus blank O2 yields 4 NO plus 6 H2O. So if we count up our oxygens on the right side now, we now have 10 oxygens on the right side. And, okay, so 10 oxygens, how many moles of O2 is that going to be? Well, it's going to be 10 over 2, which equals 5, so we're going to have 5 O2. So our final formula is going to be 4 NH3 plus 5 O2 yields 4 NO plus 6 H2O. Alright, that's all I've got for 4.1 balancing chemical equations. I hope you enjoyed it. I will be back for 4.2. Good day, everybody. Good night.